All right, so we're going to go on to our next section, and it's going to include sections 1.2 and 1.3 of the book, and this one is called angles. Make sure you put this as your title right there, okay? So let's define what an angle is. An angle is formed by two rays that share a common endpoint. The common endpoint is the vertex, and then the rays we refer to as the sides. Okay? So pause the video if I'm going too fast, because you'll need to write all of this down. Okay? So all three bullets. Here's what a picture of an angle looks like. So just to kind of put two and two together, this is a ray, this is a ray, and here's the vertex right here. We sometimes measure them in degrees, okay, when we want to do the problem associated to that. Here's how you name the angle, okay, here's how you name the angle, right here. Here's the angle symbol, and you have to put the letters in order to where A, which is the vertex, must be in the middle. Okay, now you can say MAT, that's the only other way I'll say that, but A is still in the middle because that's the vertex. Okay, now because this is an only angle all by its lonesome, sometimes you can name it with just the vertex, which is angle A. Okay, so all three of these names are good. Okay, to pinpoint, you know, again, some of the parts. Okay, the vertex is point A, the sides are ray AM and ray AT. Okay, so that's an angle. Congruent angles, we talked about congruent last unit, last section. That means same size and shape. So if we're talking about congruent angles, those are angles whose measures are equal. So sometimes they're like this, or if they don't, let's say they didn't have these measures right here. If they didn't have those measures, then you'll see these tick marks in the interior of the angle. Okay, and that signifies that they are congruent. Protractor, you might have used it a little bit, but it's basically the tool that measures angles. So if I wanted to measure some angles here, you want to place the vertex of the angle. So for instance, let's measure angle AEB. So here's AEB. I want to place one of the rays on the 0 over here, and the vertex E at that little center. And so then I kind of just check to see where this ray meets the protractor. So that looks like it's about 90, between 96 and 97. So we'll just say that the measure of angle AEB is 97 degrees. Okay. And then let's say I want to measure angle BEC. Well, you want to still place this at the vertex, but there's not any that is at the 0. So what you want to do is you want to rotate your protractor so that one of the rays is at the 0. So then I'm looking at the inside numbers: 0, 10, 20, 30, 40, 52. Looks like between 52 and 53. So we're going to just say 52. So the measure of angle BEC is about 52 degrees. Okay? And then you can measure any of them like that. Okay? So follow the angle measure. Okay, so let's talk about constructing an angle. Okay, how do we construct congruent angles? So we'll need our protractor, our compass and our straight edge. And so here are the 4 steps on how to copy an angle. You'll first start off with let me get my highlighter. You'll first start off with a ray, okay, down here. Then you'll make an arc on the angle that we're copying and make that same arc on the ray that we started. Then you'll measure from C to B with your compass, and then you'll come down here at E and make an arc there. After that, you'll get your ruler and just connect from D through that intersection point. Okay, so let's practice it together. So if I'm going to copy this angle exactly as it is, I don't want to use my protractor. I have to use my compass. Okay, so let's start off with the ray. Start off with the ray. Okay, and let's just call it A. Then let's make an arc on the angle that we're copying. Okay, we have to make an arc. You don't want your arc to be super small, but you don't want it to be super big either. So like somewhere around the middle right there. Now, without moving your compass, come over to A and make that same arc. Okay, off that side. Now, what I want you to do is I want you to highlight these 2 points. Okay, this one and this one. Those are 2 very important points because we want to get our compass now and go measure how far apart those are. So place your compass at that intersection point and this intersection point. Okay, pause the video if it's going too fast for you. Okay, so pause right there, measure that. After you did that, you want to come over here, and we should probably label this one. Let's label this one before we move on. This point right here, we're going to call B. So measuring those 2 yellow dots on how wide the angle is, you're going to come over here and now place it on B. And so that's how wide it is, so you want to make an arc here. So I'm going to highlight with my yellow the same situation. That one and that one is the same width as the original 2 yellow highlighted points. So now all we have to do is get our ruler, line it up with A, and line it up with this yellow intersection point. And go ahead and extend another ray. Okay, let's call this other yellow point C. Okay, so if this were to be angle X, Y, Z, we have just created an identical angle ABC. So we're going to say angle X, Y, Z is congruent to angle C, A, B. How many arcs does it take? 1, 2, 3 arcs. 3 arcs minimum. Okay? That's copying an angle. Okay, so let's move on. Angle bisector. Definition of an angle bisector. Well, we've talked about a bisector before in the past, so now we're just going to put it on an angle. It's a ray that divides the angle into 2 congruent angles. So let's put a picture to that. So we have our ray right here in the middle that I'm going to highlight yellow. So this ray right here. That cuts the angle exactly in half. Okay, because that's what bisect means. So this angle is congruent to this angle. So you can now see over here, angle DAW is congruent to angle WAG. Okay? Now, if they're congruent, they're going to have the same measure as well. So if this is 40 degrees, this is also going to be 40 degrees. Okay, which goes back to this right here. Everybody always wonders, what does the M mean? It stands for measure. Okay, so the measure of DAW was 40, which means this has to also be 40, because it's the measure. All right, and I'm just making that number up. You gotta actually figure out what it is if it's asking for that measure. Okay, angle bisector. So now let's construct an angle bisector. Okay, this one's a little easier than copying an angle. So if you have an angle, all you do is you start off by making an arc, like this red one that you see, I'll highlight it in yellow. You make an arc, any size, it doesn't actually matter. Then you measure from here to here, okay, more or less, as long as it's more than halfway. You don't want to have it so small. Make an arc in the center, then place it on the C and make another arc so that they intersect. And then all you have to do is connect the ruler from there into that intersection point. Okay, so let's practice that together. And again, pause the video if I'm going too fast, or rewind, or whatever it takes. Okay, so let's do step one. Step one's easy. Place it on the vertex. And then pick a compass setting, not too big, not too small. Okay, but right in the middle. And then make an arc. Okay, so I'm going to highlight the 2 points that are important, these two right here. I'm going to place the compass at one of the intersection points. Okay, and you can make it the same size. What I was saying earlier is you don't want to make it too small. It's got to be more than halfway. So if you get close to that point, you're going to be good to go. Make an arc in the middle, place it on the other intersection point, and make an arc in the center, in the interior. So this intersection point is important. So what you want to do is you want to connect the vertex with that, and it should be perfectly right down the middle. Okay. So now let's just connect with another ray, make another ray there, like that. Okay, so now with these 3 arcs minimum, you will lose no points on the homework assignment or the quiz. 3 arcs minimum. Okay, you don't really want to do this any other way, because there are some constructions that you can do multiple ways, but this one's just one. And remember, once you do that, that means these 2 are congruent, just to reiterate. All right, and that's constructing an angle bisector. Okay, let's go on. Some more definitions, skew lines. Here's the definition: lines that do not intersect and are non-coplanar. Do not intersect and are non-coplanar. So you have these 2 red lines. One is, and think of 3D, okay? One is up here, and one is down here. Those 2 would never intersect, okay? Because it's like on the floor. Imagine this is our classroom. This line in is on the floor. This line in is on the ceiling. There's no way they would ever intersect, okay? Now, if you're thinking that they're going to intersect over here, you're not thinking in 3D. Okay, so you have to think in 3D. Okay, so those are skew lines. Moving on. This you did in middle school, so we're just going to review these real quick. Right angle, acute angle, obtuse angle. These are all real simple. I have a picture of each one. A right angle is exactly 90 degrees. An acute angle is less than 90 degrees, okay? And then an obtuse angle is less than 180 degrees, but greater than 90 degrees. Okay? Less than 180, but greater than 90. Okay, so this is the angle measure. Because those symbols kind of look alike. Measure the angle greater than, measure the angle less than. All right, moving on. Adjacent angles. Okay, I'm pretty sure you might have heard of the word adjacent before. Okay, if not, this is not that difficult. Angles that share a common rate. Okay, and anything could be adjacent. For right now, we're talking about angles. Okay, so right here, you would say that we'll call this angle 1, and we'll call this angle 3. Okay? Angle 1 and angle 3 are adjacent because they share that ray. Okay? Lots of different things can be adjacent. Moving on. Complementary angles. Okay, I'm not sure if you've heard of this one before, but whenever angles are complementary, their sum is always going to add up to 90. Okay, just like they have in those examples. Supplementary are going to be angles whose sum measure up to 180, just like these two examples. This one doesn't show any examples, but you should know by now that from here all the way back to the same line is always going to be 180 degrees. Okay? Pause the video if I'm going too fast. Make sure you get all these notes down. Okay? And then you got to go back and study them. We'll go over them in class tomorrow. Okay, so vertical angles. What are vertical angles? So let's give you a list of vertical angles over here on the pictures over here. Okay, so over here we've got angle 1 and angle 2 that are vertical. You've got angle 3 and angle 4 that are vertical. So I'm kind of just using some colors to match them up. You've got this angle here that's vertical to this one. And lastly, you've got this angle here that's vertical to that one. Okay, and all of these over here are not vertical. So if you want to actually write them down, you can. You don't have to if you color coordinate it, but angle 1 and angle 2 are, angle 3 and angle 4. Over here, we're not going to write them all down, just one pair. Angle BEA and angle DEC. Okay? So, what would be a good definition? Okay, it's going to be two angles formed by intersecting lines and are non-adjacent. So we had kind of just talked about what adjacent is. So these are going to be non-adjacent. So they're not right next to each other. Notice this green one over here and this other green one over here, the angle 3 and angle 4, they're not next to each other. They're on opposite ends, so non-adjacent. Okay, so those are vertical angles. Okay, linear pair. Linear pair. So let's go over what consists of a linear pair. Angle 3 and angle 1. Angle 2 and angle 4. Now there's more. Angle 3 and angle 2 are also a linear pair. And then even these over here, angle 1 and angle 4. Okay, same thing down here. This angle 1 down here is a linear pair with angle 2. And we're going to skip this picture, okay, because that should be a good enough example. So if you want to write them down, you can. Okay, so in this case, we've got angle 1 and angle 3. Angle 1 and angle 4. Angle 2 and angle 4. Angle 2 and angle 3. And that's it. And then of course down here you've got angle 1 and angle 2. You don't have to write those down. Alright, so if those are all linear pairs and all of these over here are not, okay, here's the best definition that we can come up with. Two angles formed by a line and a ray. So two angles formed by a line and a ray. Think back to what a ray is. A line and a ray. And they are adjacent. So these are always right next to each other. Okay? These guys are always going to be right next to each other. These are adjacent. If they're not adjacent, then they're not a linear pair. So be able to identify a vertical angle and a linear pair in the homework and on the next test. Angle addition. This is very similar to segment addition. Okay? So if D is in the interior, okay, anywhere in the interior, so D is anywhere in here, all right? Then let's make a ray. Okay, so I'm going to put it down here. So that's point D right there. So if you have these, you now have 3 angles, okay? And I'm going to color them in different colors. You have this angle, that's red. You have this angle, that's green. And you have the entire angle that I'm going to color now in blue. Okay? So basically, the red angle, which is angle CAD, like that right there. If I add that with angle DAB, which is this one right here, then that has to equal the whole entire angle, which is CAB. Like right there. Okay, so that's just to put some color coordination to it. So just like this, we did with the segments, we're going to do that with angles. Okay, so let's do a couple of examples and then we are done. So here, we have to draw the picture in order to make it look fairly easy. Okay, because whenever you just read it in words, it's kind of hard. So let's draw a big angle, AXS, and then it says R is in the interior. Here's R. Okay. Now let's write down some measures. It says angle AXS, and here's where it's good to use colors. So that whole thing is 76 degrees. RXS, they said, is x plus 12 degrees. AXR, in blue, is 7x plus 4 degrees. Find x and find the measure of all the angles. So this is very similar to that segment addition that we did on 1.1. So let's add the 2 little angles and set them equal to the 76. Okay, so I'm going to add them in my head. 7x plus x is 8x. 4 plus 12 is 16. Set it equal to 76. Okay, so I'm going to do a little bit of algebra. I'm going to minus the 16. So then I have 8x equals 60. And so 8x divided, or 60 divided by 8 is going to be a decimal. So let me see what that is. 7.5. Okay. So I know that x is 7.5. So now what I want to do is I want to plug that in to each little angle. Okay. So for the green one right here, the green one, angle RXS, that measure is 7.5 plus 12, which is 19.5 degrees. Okay? And then the blue one up there, you can plug it in if you want, or you can just subtract 19.5 from 76. So the blue angle, the measure of angle AXR, that's going to be 56.5 degrees. Okay, so this is angle addition. All right, last one. Last one. This one deals with an angle bisector, so that's what makes this one different. So I have angle ABC, and it says BD is the angle bisector. So let's draw this nice and perfect. So here's A, B, C, and BD is the angle bisector. So I'm going to put tick marks in the middle of each angle to remind me that they are equal. That's the definition of angle bisector. Okay, so now let's label our picture. Let's label our picture. So it says ABC, so the whole thing from there to there is 5x plus 32 degrees. Then DBA, which goes from, let me get a different color, from here to here, that one is 4x plus 4 degrees. Okay, now I gotta find the measure of all the angles. Okay, well, This right here should be kind of ringing in your head. These are equal. If this is 4x plus 4, well, this can also be represented as 4x plus 4. So now it looks like the problem that we just did, guys. So that's the hard part, and if you can get that, it should be pretty easy. So I have 8x plus 8. I added those two in my head, and I set it equal to 5x plus 32. Okay, let's do some algebra. I'm going to minus the 5x, and I'm going to minus the 8. So then I get 3x equals 24. 3 goes into 24 8 times. So now if I want to plug it back in, so that way I can determine each angle, okay? I'm going to plug it into, I'll just plug it into this large one, ABC. Angle ABC, 8 times 5 is 40. What's 40 plus 32? 72 degrees. So if that angle is 72, what is each little one, which happen to be equal? What's 72 divided by 2? 36. So this angle is 36, and this angle is 36. Okay? And that is it.